What's up guys, welcome back to another physics video by myself, Krishay Patel. Today we'll be talking about energy specifically, and we'll speak about the principles of energy conservation as well as collisions taking place and the loss of energy that could occur. So let's begin. An overview of today's lesson. We'll have an introduction to energy followed by the types of energy that you can get. We'll then dive specifically into kinetic energy and the kinetic energy equation, potential energy and the potential energy equation, and then mechanical energy, followed by our conservation of energy and then law of conservation of mechanical energy, and then ending our lesson off with the types of collisions that you can get. So let's begin. Energy is a fundamental concept in physics that describes the ability of an object to do work. It can take many forms, including kinetic, potential, thermal, electromagnetic, or even nuclear energy. Understanding energy is crucial for understanding the behavior of physical systems, from the motion of an object to the behavior of atoms and molecules. Energy is also important in everyday life, from powering our homes and transportation to fueling our bodies. Without energy, nothing would happen in the universe. So what are the types of energy that we can get? Well, we've spoken about energy being a fundamental concept in physics and how it describes the ability of an object to do work. We've also spoken about the many types of energy that there are, but the two main broad categories that we'll be discussing energy and classifying energy as are kinetic and potential energy. So just to speak about these two forms before we dive specifically, kinetic energy is the energy an object possesses due to its motion. The amount of kinetic energy an object has depends on its mass and velocity, while potential energy, on the other hand, is the energy an object possesses due to its position or configuration, generally referred to as its height due to a specific reference point. The amount of potential energy an object has depends on its height above a reference point, as well as any forces acting on it. Just to classify, if we look at the image on the right, we'll see the other types of energies that exist as well and what they sort of entail. So kinetic energy and the kinetic energy equation. So what is kinetic energy? Well, we've spoken about it, but kinetic energy is the energy an object possesses due to its motion. So as seen on the right here, this image of a car traveling extremely fast within the streets of some city is clearly experiencing kinetic energy due to its relative motion. It is defined, or kinetic energy specifically, is defined as 1/2 of the mass of an object multiplied by the square of its velocity. So if we take a look at this equation right here, EK or KE being your kinetic energy is equal to half the mass of the object multiplied by its velocity measured in meters per second squared. The kinetic energy of an object can be increased by increasing its mass or velocity. For example, a car traveling at 60 miles per hour has more kinetic energy than that same car, due to it having the same mass, traveling at half the speed of 30 miles per hour. Now we'll talk about potential energy and the potential energy equation. Potential energy is the energy that an object possesses due to its position relative to other objects. It is a form of stored energy that can be converted into other forms of energy such as kinetic energy. The potential energy of an object depends on its mass, height, and the acceleration due to gravity. Potential energy is also sometimes referred to as the energy or the work done against gravity. The equation of potential energy is given as follows. PE or EP, your potential energy, is equal to your mass in kilograms multiplied by your gravitational acceleration, which is generally 9.8, multiplied by the height at which the object is located at a particular time from a particular reference point. The equation shows that potential energy of an object increases with its mass and height. Additionally, the higher the object is positioned, the more potential energy it has. In terms of transforming energy and energy being transformed from one form to another, we'll discuss that later. But if you want to have a quick look, if we look at the image on the right, we see this, where the object possesses potential energy here, but as it's dropped, that potential energy slowly is transformed into kinetic energy as it decreases due to its reduction in height. Now we move on to mechanical energy. Mechanical energy, as shown on the right-hand side with its equation, is the sum of the kinetic and potential energy of an object at a particular point in time. Kinetic energy is the energy, again, associated with motion, while potential energy is the energy stored in an object due to its position or state. For example, a ball at the top of a hill has potential energy because of its height above the ground, As it rolls down the hill, this potential energy is converted into kinetic energy. The total mechanical energy of an object remains constant as long as there are no external forces acting on it. This principle is known as the conservation of mechanical energy, which we'll delve into a bit later. For example, if a roller coaster car starts from rest at the top of a hill, its initial position and its initial potential energy is converted then into kinetic energy as it moves down the hill. At the bottom of the hill, all of the initial potential energy would have then been converted into kinetic energy as its height then becomes zero, and so it loses all its potential energy. If there are no external forces acting on the car, the total mechanical energy is also said to remain constant throughout the ride, but we'll touch on that later. Now we move on to a very important concept and principle of physics, which is the conservation of energy. The conservation of energy just states that energy cannot be created nor destroyed, only transformed from one form to another, meaning that the total amount of energy in a closed system remains constant. So if energy decreases, such as the case in the image on the right here, where we start off with a high bar of kinetic energy, but then it changes, it doesn't mean that energy has just been lost. It just means that that kinetic energy has been transformed into another sort of energy or form of energy, as seen in this case with our potential energy bar then increasing. When we apply this principle to mechanical energy, we see that the sum of kinetic and potential energy in a system is always constant as long as there are no external forces acting on it. This means that if an object loses potential energy, it gains an equal amount of kinetic energy and vice versa, which again is seen in the image on the right hand side. Now we move on to the law of conservation of mechanical energy, which just states that the total amount of energy or mechanical energy in a closed system remains constant, meaning that energy cannot be created or destroyed but only transformed from one form to another. This law applies to both kinetic and potential energy and is an important concept in physics. One application of the law of conservation of mechanical energy is in a roller coaster, where a roller coaster car is at the top of a hill. It has a potential energy due to its height above the ground. As it travels down the hill, this potential energy is then converted into kinetic energy. At the bottom of the hill, the car then has a maximum kinetic energy and a minimum potential energy as its height then becomes zero. The law of conservation of mechanical energy ensures that the total energy of the system remains constant throughout the ride. Now we finally move on to collisions, elastic and inelastic collisions. When two objects collide, there are different types of collisions that can occur. Elastic collisions are those where the total kinetic energy of a system is conserved, meaning that the objects bounce off each other without any loss of kinetic energy taking place. While in contrast to this, inelastic collisions are those where some or all of the kinetic energy is lost as the objects stick together or deform upon collision. The conservation of energy principle applies to both elastic and inelastic collisions. In an elastic collision, the total mechanical energy, kinetic plus potential, is conserved, while in an inelastic collision, only the total momentum is conserved. The difference in energy conservation between these two types of collisions can be illustrated with a graphical representation of the object's velocity before and after the collision. Just to explain a bit further about inelastic collisions and how it relates to conservation of energy. Due to there being a reduction in some or even all kinetic energy, this doesn't just mean that energy is lost, because remember, energy can't be lost. Instead, it indicates that energy has been converted, or kinetic energy has then been lost due to that energy being converted into another form, such as thermal or heat energy, or through the energy lost when the object is deformed for a particular amount of time. So as shown in the right here, we see in the image an example of an elastic collision up top here, where after a collision between ball 1 and ball 2, the amount of energy that they still experience remains the same. Whereas in the bottom here, we see that after the collision, the energy that remains in the system experienced by the two objects has decreased, meaning that that kinetic energy would have then been converted into another form. So I hope you've understood and learned a few different things on energy and collisions and conservation of energy in this session. I hope you've enjoyed, and I'll see you on the next one. Peace.